All right, we already know how to solve quadratic equations. They look like this, they're in this form. We've got some x squared, some x's, some other numbers, and we let them equal 0. And if they equal 0, we've got three things that we can do with them. We may or may not be able to factorise, but we can also use the formula or we can complete the square. So we need to be on the lookout for tricky looking equations that we can actually make look like this, because if they do, we can throw our equation solving skills for quadratics at them. Now, some tips. You may or may not be given a suitable substitution to use. So this first example here, we've been given something, which is nice. Use u equals e to the x to solve this. Now, when you first glance at this, it doesn't automatically look like one of these because we don't have something squared and then something that's not squared. This one here looks like it has too many x's in it, or the x's are in different places, so it's not automatically obvious that it's one of these. But once we make our substitution, it should be more obvious. Now, if they haven't told us what to use, generally you can let u equal the simplest part of the exponential expression. So here, the simplest part here is e to the x. This e to the 2x looks a little bit complicated, so if you're not told what to use, picking out that nice simple one that's in the middle, presumably in the middle, is the one to go for. Now, a word of warning, you might need to manipulate some expressions to make your quadratic look like this. So in this example here, we can use the substitution we've been given. A little bit of thinking to do beforehand is that e to the power of x is not what we have here. So if you just jot down the exponential part here, note the number of disguises this thing has. Some of them will be useful and some won't. You can write this as e squared to the power of x. You can also write it as e to the power of x squared. And that's the one that we want because it uses the substitution that we're going to need. This is not helpful. I was just thinking through all of the ways I can put this thing into different disguises. Now, the more complicated questions might get you to arrange and rearrange something multiple times before you get it looking right. But I'm ready now to use this. So if I've got 3 lots of this, then I'm going to have 3u squared. And you can do that thinking in your head or in the margin. The more you do, the better you'll get at it. So we've got 3u squared minus 11u minus 4 equals 0. Now it looks like one of these. Now, can we factorise it? Well, 3 times minus 4 is minus 12. Have we got factors of minus 12 that add to make minus 11? Yes, plus 1 and minus 12. So I'm going to go ahead and split up my minus 11u into plus u and minus 12u. And now I can factorise these in 2 pairs. I'll bring the u out the front here. And over here I'm going to need minus 4, 3u plus 1. And now bringing these together, u minus 4 and 3u plus 1 is equal to 0. So either this part's 0, in which case u equals 4, or this part's 0, in which case 3u is going to equal minus 1, and u will equal minus 1/3. Now, I'm not finished because my question asked me to solve for x. So at this point, I need to keep on going. I'll keep going over here. This means that e to the x is equal to 4, or e to the x is equal to minus 1/3. Now, this one here I can tell straight away isn't going to work. E to the power of x is always positive. It can't be negative. So I'm just going to put a not equal there, and that shows that I've thought about it and I've decided that that's not one of my solutions. Now I can focus on this one. I'll rewrite it as a log. E to the power of x equals 4, and that's my answer. X is equal to the natural log of 4. Here we've got an example that's a lot more tricky. It's firstly tricky because it doesn't really look anything like this form. For a start, we've got 2 terms on one side and 1 on the other, but don't be misled, we can easily add 12 to both sides. But the other thing is that the 2 exponential parts don't have the same base, so it's tempting to think that they're not related. But have a closer look, we've got 2 and we've got 4. And we know that 2 squared is 4, so we're going to be able to fiddle with these ones and get them looking right. Now, first thing to do is to fiddle with 4 to the power of x and see if we can get it in terms of 2. So do that over on the side, or you can do it in your head. If we know that 4 to the power of x is the same as 2 squared to the power of x, then that's the same thing as 2 to the power of 2x. Now, is that ready to go? Well, it's not looking exactly like this one, is it? But remember what we thought in the last example, 2 to the power of 2 raised to the power of x is actually the same thing as 2 to the power of x raised to the power of 2. And last time it was this one that we wanted, but for this example, we actually want this version. So you need to be prepared to play around with an expression and put it in as many disguises as you can until you find one that you think will work. Now, the reason this one will work is because now we've got something that we can use as u, and we've got -7 of them here, and here we have some of them squared, so it's looking like one of these. So I'm going to write exactly what u is. Let u be 2 to the power of x. And remember in my hints section, I said generally you want to let u be the simpler of your two expressions. Okay, so here I've got u squared minus 7u, and now I'm adding 12 to both sides, so I can have that over here. And now it looks like a quadratic, and it's really quite straightforward to factorise. I need factors of 12 that add to -7, so it's going to be -3 and -4. So that means u equals 3 or 4. But I'm not done yet. I have to solve 2 to the power of x equals 3, or 2 to the power of x equals 4. Now this one's straightforward because I know that 2 squared is 4. So in this one, x equals 2. But for this one, I need to just rewrite it as a log, because 2 to the power of x equals 3. That's what I've written here, and I've just reversed it. So then at the end, I can make my answer very clear. X is equal to, I'll write the simple one first, and the slightly more complicated looking one second.